Integrated Math 3. This is lesson 5.01. We're in our final unit of the course. It's called Trigonometry. And this is a area of math that if you're going to go on into further math or into any science or engineering subject, pretty much any science or engineering subject, you're going to use this. So this is a very practical type of math for people that are in science and engineering. So we're going to go ahead, I'm going to work through this assignment. Remember that if you plan to go on with math, be sure you know how to do these problems, okay? Otherwise, just get the assignments done and get them in and get through this class, okay? All right, so let's get going. So 5.01, Trig SOH CAH TOA, we'll talk about what that means here in just a second. So trigonometry has many applications in many areas. And there's many of the applications, trigonometry seems different than in other applications. It seems like it's a completely different thing. Trigonometry can apply to triangles, as you see on this page here, or it can apply to waves, like light waves move in a trigonometric pattern. So I'll explain that as we go along and as we learn this subject, okay? All right, so let's go ahead and get started. So at one point along the way, you learned about the Pythagorean Theorem, and I'm just going to give you a quick example here of that. And you learned that probably several math classes ago. You may not remember it, but it's there somewhere. And so I'm drawing a triangle. And specifically, this is a right triangle, meaning this is a 90-degree angle, and you usually represent that by a little box there. So a 90-degree angle isn't the angle that you have in your room, in the room that you're sitting in, between the wall and the floor. Okay, it's called a right angle sometimes, and it's 90 degrees, so we can write that. You don't usually write the number, but we'll go ahead and do that. Okay, so a couple of principles. First one about triangles is that the sum of the angles of a triangle must equal 180 degrees. So if I have angle A, angle B, and let's call this one angle C, and I could have called any one of them A, B, and C. It doesn't matter. And sometimes the way you represent an angle is with that little angle symbol. So angle A plus angle B plus angle C for any triangle always equals 180 degrees. Okay, all right. Now, for a right triangle, there's a law called the Pythagorean Theorem, and it says if you label sides A, B, and C, it says that A squared plus B squared equals C squared. And this principle was discovered many thousands of years ago by the ancient Greeks. They learned this principle. Okay, which side is C? Well, C has to be the longest side, and the longest side is called the hypotenuse. Okay, hypotenuse is the longest side, so C must be the longest side in this equation. The other two sides, A and B, it doesn't matter which one you call A and which one you call B. I could have switched those around. It doesn't matter. So let's take an example. Let's say A equals 3. Let's say B equals 4. Whatever you want it to be, 3 inches, 3 feet, whatever. Okay, let's just say 3 inches. 3 inches, 4 inches. Then we want to know what C is. Okay, so we plug into this equation here and we say 3 squared, that's A, plus 4 squared, that's B, equals C squared. And if you do 3 squared, you get 9, plus 4 squared, you get 16. So that equals C squared. 9 plus 16 is 25, equals C squared. So you can now take the square root of both sides to find out what C is. The square root of a square is just going to bring you back to C here. So the square root of C squared is C, and the square root of 25 is 5. So that means that this side over here has a length of 5, okay? It's a very common triangle called a 3, 4, 5 triangle. The Pythagorean theorem only works when you have a 90-degree angle there, a right angle. If there are no right angles in this triangle, then you can't use the Pythagorean theorem. Okay? So that's something you've learned a few math classes back, was the Pythagorean theorem. And what it says in general is, if you know any two sides of a triangle, the length of any two sides of a triangle, you can figure out the length of the third. If we had not known what the length of side B is, for example, but we did know that this was a 5 and that this was a 3, we could have just rearranged the equation and said 5 squared minus 3 squared equals 4 squared, taken the square root of that, and you would have gotten 4. So if you knew the hypotenuse in one of the other sides, you could figure out the unknown side, okay? In this case, we just made these two sides the knowns and the hypotenuse the unknown, okay? So that's something that you learned some time ago, and what it means basically is if you know any two sides, you can figure out the third side as long as you have a right triangle using this. What trigonometry says is if you know the length of one side, here's another triangle, and an angle. So again, it has to be a right triangle to do what we're going to do. But instead of knowing two sides, the distance or the length of two sides, you know one side. Let's say we know the adjacent and an angle. We can figure out both the hypotenuse and the opposite side. If we knew the angle and the opposite, we could figure out the hypotenuse and the adjacent. So one side and one angle other than the 90-degree angle. So you really know two angles, in other words. You know the 90-degree angle and whatever this angle is, theta. Theta is commonly used, it's a Greek letter, and it's commonly used to indicate, to represent an angle, an unknown angle, or an angle that's known if you put theta equals some number. Okay, now let's talk about this. It's very important you understand that the sides, this time the sides are very specific sides. So the hypotenuse, again, is the longest side. Okay. Now, if this is the angle theta we're interested in, we could have been interested in this angle, but we're not for this problem. Let's say this is the angle we're interested in, then the opposite side is a side all the way across the triangle from theta, from this angle. So that's called the opposite. Adjacent, the word adjacent in general means next to something. So the adjacent is the side next to theta, next to the angle theta. Now the hypotenuse is also next to theta, but it already has a name. We call it the hypotenuse. So the adjacent is the other side that's next to theta that's not the hypotenuse. So hypotenuse, longest side. Opposite is the side all the way across the triangle from the angle you're dealing with. And adjacent is the side right next to the angle that's not the hypotenuse. Okay, so let's go ahead and see some relationships here. And for this assignment, you have this table to work with, and you're going to constantly be referring to this while you learn this. Okay, so we have three fundamental functions in trigonometry: a sine, a cosine, and a tangent. The three down at the bottom are kind of secondary functions, and we're not going to deal with them at all today. Okay, so you can ignore these three down at the bottom. We will use them in some future assignments. So what is the sine of an angle? It's simply a ratio of two of the sides. It's the opposite over the hypotenuse. So if we know what the value of this opposite is, what the length of this side is, and we know the length of the hypotenuse, then if we put the opposite over the hypotenuse, that's going to give us something called the sine. It's abbreviated SIN, but you still say sine. Okay? So that would be the sine. The cosine, which is abbreviated COS, so when you see that, you don't say cos, you say cosine, is going to be the adjacent over the hypotenuse. It's this side over the hypotenuse. So if you know the value, the length of this side, the length of this side, you can figure out what the cosine is. Okay? And the cosine, by the way, the sine and cosine we're talking about is specifically of this angle theta. So notice that these sides are all in relation to this angle theta. The adjacent is this side, the opposite is this side. If we had chosen this angle up here to work with, then the opposite would have been this side. This side would have been the opposite, and this side would have been the adjacent. The hypotenuse doesn't change, it's the longest side. So when you say these sine, cosine, it's of a particular angle, and in this case it's of this angle. Okay, tangent is the opposite over the adjacent. It's this length over this length equals the tangent of angle theta. Now this is all very vague and confusing right now, so the best way to do this is just jump in and do some problems, and you'll see how if you know what the angle theta is and any one of these three sides, you don't have to know more than one of these three sides, you can figure out the length of all the other sides. And you can also figure out, by the way, if you know the angle theta, of what the other angle here is. So we're going to do that, all right? Okay, so let's get started with a problem. Again, you're going to be referring back to this, all right? Okay, so let's go ahead and do some problems. On the first page is problems 1 and 2. I'm going to start with problem 2. It's actually a little bit easier problem than problem 1. So let's go ahead and do this. So what they want you to do is find the cosine of this, all right? And the first thing I always want you to do when you do these problems is, here's our angle theta. I want you to identify the opposite, the adjacent, and the hypotenuse. So the opposite is the angle across here. The adjacent is the angle next to theta. Well, the hypotenuse, let's identify that first. That's the longest side. So that's the hypotenuse. And then the side next to theta that's not the hypotenuse is the adjacent. Okay, so they want us to find cosine theta here. So we come over here and we find cosine, and cosine is adjacent over hypotenuse, right there. So we simply are going to make a ratio of the adjacent over the hypotenuse. So cosine equals adjacent over hypotenuse, and that equals 5 over 13. And that's the answer. That's all you have to do for that problem. All right, so that's what they're simply saying. That's equal to the cosine. Okay, let's go up and do number 1. They want you to find the tangent. So the first thing you do is you label your sides. Here's the angle theta. So the longest side of this one is this side with the 13. That's the hypotenuse. Okay. Then the opposite side, you come all the way across the triangle. That's going to be the opposite. And then the other side, sometimes I just think of it as the other guy, is the side that's next to theta that's not the hypotenuse, and that's the adjacent. Okay, so we come back and we need to find the tangent. So let's do that here. So tangent is opposite over adjacent, right there. So here's the opposite. We know that it's 12. And here's the adjacent, but we don't know what the adjacent is. So we have to calculate it. Now, there's a way to do that. There's a couple ways to do that, one using trigonometry, but right now you don't know enough trigonometry. But what you do know is the Pythagorean theorem. Okay? So we're going to calculate this side using the Pythagorean theorem, and once we have the adjacent and the opposite, which we already have, we can figure out what the tangent is, okay? So the Pythagorean theorem again says that a squared plus b squared equals c squared. So now we have to label our sides. The hypotenuse is always c in this equation, always. A and b, it doesn't matter which is which. We're going to say that the adjacent is a and the opposite is b. So we know the opposite and the hypotenuse. We need to find the adjacent. So we need to find a. So we're going to solve this equation for a. So we're going to subtract b squared from both sides. This cancels out, b squared minus b squared. And what you have is a squared equals c squared minus b squared. Okay, and we're trying to find a. So there we go. There's the equation. So let's go ahead and do that. A squared equals c squared is 13. 13 squared minus 12 squared. So a squared equals 169. You do that on a calculator if you don't have it memorized. You're not expected to necessarily. And 12 squared is 144. So 169 minus 144, a squared is going to equal 25. And now you take the square root of a squared, take the square root of both sides, because we're trying to get to a. The square root of a squared is a, that's what we want to know. The square root of 25 is 5. Okay, So that means this side over here is 5. Just write it right here. So now we know the adjacent and the opposite. So the tangent equals the tangent. I shouldn't just write tangent, and I shouldn't have just written cosine here. Let me go back and correct that. It should be cosine theta. It's the cosine of an angle. Cosine or sine or tangent are always of an angle. So let me correct that and make that. So this is going to be tangent of theta equals opposite over adjacent. Again, you just got that from right here. Tangent, opposite over adjacent. And so the opposite is 12 and the adjacent is 5. So we just write 12 over 5. And you don't have to convert that to a mixed fraction. That's really the answer right there. Okay? Alright, so this one was one more step than this one down below. Okay? Let's keep going. Now the next problems are going to actually get us into using the sine, cosine, and tangent to figure out the sides. Here we haven't done that. We've just kind of we just seen the relationships there. Okay, so let me move on to here, number 3. Okay, and don't be confused because they might turn the triangle on a side like that you're not used to seeing that. Just remember that's a 90-degree angle. Okay, and that's a 30-degree angle. And we usually show an angle by kind of an arc like that. That's an angle right there. Okay, so that is the angle theta. So theta equals 30 degrees here. Okay, so it says find the measure for the side indicated. Round to the nearest tenth. I don't care about the rounding necessarily. I'm going to actually have you find for both sides, and I also want you to find, this is angle B, angle C, and angle A. I also want you to find what angle A is. What's that angle right there? So we're going to find all 3 sides and all 3 angles, okay? First, let's do what the question asked us for. Find the measure for the indicated side. So that's x. They want you to find x first. Okay, so the first thing you do in every one of these problems is label the sides. The longest side is the hypotenuse. Okay, then here's the angle that we're interested in. The side across the triangle from it, this side with the x, is the opposite. And then the other one that's next to the angle that we're interested in is the adjacent. Okay. All right, so what you want to do is you want to find a relationship for this angle that includes your unknown, which is x, that's the opposite, and your known, which is 12 here, that's the hypotenuse. So we're not interested in y right now. Let's keep that off to the side for now. Let's figure out what this side is. That's the side they first asked us about. So it's a relationship between the opposite and the hypotenuse. In other words, our unknown and a side that's known. So there's unknown, known, so it's opposite hypotenuse. So we come back to the sheet here, and that relationship is going to be the sine. Notice it's the only one of these 3 that has opposite and hypotenuse. The other 2 have something else. Okay, opposite hypotenuse. So the sine is the opposite over the hypotenuse. Okay. So the way you write that is the sine of the angle theta, which in this case we know it. It's 30 degrees. Equals opposite over hypotenuse. And in terms of the values that we see on the triangle, the opposite is side x. That's what we're trying to find out the length of. And the hypotenuse, we do know that number, it's 12. So you always have to have the side you're trying to find, and then one known side. So the known side is this one, okay? All right, so now that I've written that, let me rewrite it just without that in it. So sine of 30 degrees equals x over 12. All right, so now what do we do? Well, you can find the sine of 30 degrees on a calculator. All right, so I'm going to use the online calculator to do that. So there's a very specific number that's going to come out to be. We saw in the previous problem, that, for example, this cosine was 5 over 13. If we divided 5 by 13, we'd come out with a decimal value for that, and that would be the cosine. So here, we're going to go onto a calculator. So to get to the online calculator, just go to Google and type in the words online calculator. Click. It brings up a calculator right away. But the one I would recommend you use is, you see the link down here. It's the very first link. It's called Online Calculator. Click on that. And now that brings up, on the home page of Online Calculator, brings up a calculator that we're not going to use. It doesn't have enough functions on it. It's a very simple calculator. So you're going to go down here to the bottom, and right here top center says Scientific Calculator. You're going to click on that. It might be the same one that was on that first page, but I have never checked it, and this is the one that we use. So this has functions that we need to use in this class. One of them was log that we used last unit, natural log, same thing. And then we need to use sine, cosine, and tangent. Okay, so in this case, we're looking for the sine of 30 degrees. So come up here, click on the bar up there, and put in 30, the number 30, and now click on sine. And it will give you what the sine of 30 degrees is. Now, it's 0.5, it's 1/2, so that one's very straightforward. You don't have to write all these zeros, just 0.5 is good enough. Okay, so we're going to move back to our sheet. And there we are. So we found out that sine of 30 degrees from the calculator is 0.5. When I was in high school taking this class, there were big pages and pages and pages of sines, cosines, and tangents for various angles. You had to look them up in a book, and my textbook had that. But you don't have to do that anymore. You have a calculator, so you do that. So that equals x over 12. So now it simply becomes an algebra problem. You need to solve for x. That means you need to get x by itself. So what we're going to do is multiply both sides by 12. Anything you do to one side, you do to the other. The 12s cancel out here. And I'm going to flip the x over to this side because we usually write x equals rather than the... I'm just moving that over, and I'm going to move all this over. I'm going to do the calculation here. So 12 times 0.5, that's really just 12 times 1/2, or half of 12, and that's going to equal 6. Okay, so that means that this equals 6. So this length of this side equals 6. So we were able to find that by just knowing an angle. Other than the 90-degree angle, we knew one other angle plus the length of one of the sides. We were able to find out that length right there. Okay? Now, let's go ahead. I'd like you to go ahead and figure out what y is. So let's come over here. And now you could do this using the Pythagorean theorem. You could say, here's the hypotenuse. You could say 12 squared minus 6 squared equals y squared. That's a squared plus b squared minus equals c squared. You solve for, the sides, okay? Like we did in the previous problem, number 1. But we're going to use trigonometry, okay? So let's go ahead, and I'm going to show you 2 ways you could do this. You don't have to do them both ways. I just want to show you. Okay, so we want to know what y is. That's our unknown. So we still have this angle here of 30. So sine of 30... Whoops, not sine of 30, excuse me. Let's go ahead. First of all, we now know 2 sides. Okay, we know the hypotenuse and we know the adjacent. So that's what we want. We want the side that we're trying to find, the unknown, and then one known side. So this one would work. So adjacent hypotenuse, what's the relationship between those? We come over here, we look, and it is cosine, is adjacent over hypotenuse. It's the only one of these 3 that has those 2 in it, adjacent over hypotenuse. So it's cosine of 30 equals adjacent over hypotenuse, which equals, here's the adjacent, it's the unknown, y, over 12. Okay, so now let's go ahead and just rewrite that without the extra words in there. Cosine of 30 equals y over 12. Okay, let's go look up the cosine of 30. So we're going to go back to our online calculator, clear it, and again we type in the number 30, and now we click on cosine, this one right here. And we get 0.866 is far enough, okay? So we're going to go ahead and write 0.866 equals y over 12. Let me rewrite that up here. 0.866 equals y over 12. multiply both sides by 12 again. Let's draw a little divider line there. Cancel, cancel. So 12 times 0.866. So we'll come up to our calculator. We have y equals, write it out here, 12 times 0.866. Okay, so I'm writing that on my paper as I'm looking at this. So I got the 0.866 on the screen already. So it is times 12, and that equals 10.39. So let me go on back to my camera. I'll show you what I was writing there. I was just going ahead and writing that. I wrote 0.866 instead of cosine 30. 0.866 equals y over 12. You multiply both sides by 12 up here. Okay. And I'll go ahead and do that here, times 12 times 12. Okay, then you come up and do, I rewrote it again. I canceled the 12s, and you get y equals 12 times 0.866, and that equals 10.39. Okay, so that's this side right here. Okay, and I said I was going to show you a second way. Let me just do that real quick. We could have done, since we had these two sides, we had these two sides also, this side also, we could have said opposite over adjacent equals the tangent of 30 degrees. I said I was going to do that, but there's not enough space here, so I'm going to leave that out. You'll see that in later problems, okay? So we did it one way. We said the adjacent over the hypotenuse is going to be the cosine, and we went ahead and went to the calculator to find the cosine of 30, and then we equated it. We know that it equates to y over 12, the opposite over the hypotenuse. That's the adjacent over the hypotenuse. Okay, that's this. Okay, and then we just solved it. All right, one more thing I want you to do is find out what this angle is. All right, so the three angles have to equal 180. So let's come down here, 180 degrees. That's true for any triangle, not just a right triangle. And that's going to equal this angle, 90 degrees, plus this angle, 30 degrees, plus our unknown angle A. Okay, and just a little simple arithmetic, 180 minus 90 minus 30 is going to equal 60. So this angle A equals, angle A is going to equal 60 degrees. So that's 60 degrees. So now you figured out, just by knowing one angle and one side, you were able to figure out all the other sides and all the other angles. Okay, and that's how you do these. So the rest of these problems are similar to this. There are a few other concepts they're going to introduce here. Okay, try to do that. Again, always try to do these on your own first, all right? So I did them in class. I did them in class, and now I'm doing them here. So see if you can do this one on your own. Just stop the video, and then when you're ready to check and see how you did it, come on back. Okay, so I'm going to go ahead and do this one now. So here's our angle. So the first thing we always do is label the sides. So if this is the angle theta, the side on the other side is going to be the opposite. The longest side, this one, is going to be the hypotenuse. And the other one, this one, is going to be the adjacent. Okay, so we're going to figure out, again, we're going to figure out this side over here eventually, but let's start with the one they asked us for, this one. So this is our unknown, and this is our known. This is our unknown side, and this is our known side. So which is which? So the unknown is the hypotenuse, and the known is the adjacent. So we need to find which of the three functions relates adjacent to hypotenuse. So we come back here. Okay. And let's see, there it is. Adjacent hypotenuse is cosine. The other two don't have adjacent hypotenuse, only the cosine, and it's adjacent over hypotenuse. Okay, so it's going to be the cosine of 59.3 degrees is going to equal the adjacent over the hypotenuse. So adjacent over hypotenuse. Okay, so let's go ahead and fill in our values down here. Adjacent is 12. Hypotenuse is our unknown x. Okay, so now we're going to go back to the calculator and find the cosine of 59.3. Down here, go ahead and just type in 59.3 and cosine. And it's 0.511. If we're going to go to that third digit after the decimal, you'd round the 5. The 5 would round the 0 up to a 1, so it would be 0.511. So we'll come on back here. Okay, this is a two-step algebra problem. It's just algebra, but it's one additional step here. You need to find x. So we're going to multiply both sides by x. These cancel. So now you have x is 12. And now you need to get x by itself, so you're going to divide both sides by this. Okay, 0.511 cancels. So now you have x equals 12 over 0.511. So we'll go back to our calculator here. And it's 12 divided by 0.511. I used the divided by the slash on my computer. That's why you didn't see me push the divided by sign. And that's going to equal 23.48. Okay, so that's this side right here. That's the hypotenuse. Okay, now I know two of the three sides. So in finding this side over here, I could either use the relationship between opposite and hypotenuse, that would be sine, or I could use the relationship between opposite and adjacent, that would be tangent. Since we haven't used that one yet, we could use either one and they'll give you the same answer. Since we haven't used this relationship opposite and adjacent, we're going to use that, okay? So opposite and adjacent come over here, and that's going to be the tangent function. It's the opposite over the adjacent is the tangent function. Okay, so we'll write that here. And it's tangent of the angle theta. We'll just put it in. Okay, so that's the relationship. So, and we now need to go and find the tangent of 59.53. So we'll go back and do that. 59.3. And now we're going to press the tangent function right here. This one right here. And that's 1.68. And now again, it's just an algebra problem. Go back to the calculator. We got the 1.68 up there already, so we're going to multiply by 12. And we get 20.21. And that's the value for the opposite y, so we'll write it right here. So now we know all three sides. Okay. The last thing I'll ask you to do is figure out what this unknown angle A is. So rather than write it like this, let's go ahead and write it. It's 180. So angle A equals 180 minus 90 minus 59.3. Degrees, okay, like that. So angle A is going to equal 180 minus 90 is 90. Now we're going to go ahead and do that subtraction. So now I found something very unusual about the online calculator, which is it has a flaw in its design. So what I'm going to do is type in 180. So again, you need to activate this window up here, 180. And I want to do 180 minus 90 minus 59.3. Okay, so you have to do 180 minus 90, and then you have to hit equal to get the answer 90. Now you do another minus of 59.3, and you hit equal, and it gives you a strange answer, 30.7. Okay, so it gives you that strange answer. The answer should be 30.7 with nothing else after it, but for some reason it's showing this, so I'm going to have to reconsider this calculator because that's just a simple subtraction. So this is going to equal 30.7 degrees. That's angle A, that's this. So now again, we found out all three sides, we know the value of all three sides, and we know the value of all three angles here, okay? All right, so that's how you do that. Let's move on. And actually, this video is, don't like to have videos much more than about 30 minutes. So I'm going to cut this one off now and continue with problem 5 on the next video.